Okay, back in our final section then. We've had a look at the basics of TCP/IP and APIs in this context. And now we're trying to explore what that means in the context of a specific API we want to build. So we're going to look at what REST is at a fairly high level, and then we'll take a walk through how we implement REST features, REST API, in the skeleton app that you've already built from last week. So let's start with some discussion on REST for a moment. First of all, what does it mean? Representational state transfer. It's not a tool, it's not a language, it's not a library, really, although we're introducing a library to support it. It's more of a pattern. It's a way of thinking about APIs that took hold about 15 years ago in the industry, and in the last 10 years, it's probably been very widely deployed. So it's not a standard way of doing APIs. Prior to REST, there were other standards. There was ones incorporated directly into Java, for instance, and their programming languages. The other standards tended to be complex, binary often, and inefficient, particularly a mismatch for using the internet, using the web standards in particular. They tended to borrow over them or under them or through them to very mixed effects. REST then says, let's just use the web as it was designed and use and develop APIs to be compatible with HTTP as opposed to fighting it. Lots of resources on this. This is a particularly good one, REST in Practice, if you're interested in reading in a little bit more detail. It's present now for quite a few years, and a very nice light style, and we'll take you into the concept very quickly. Essentially, we're using a HTTP and particularly links correctly. That is, we're using them as designed by the original HTTP designers in the 80s and 90s, rather than repurposing them in new and perhaps rather awkward ways. And it's centered around 5 principles that are very simple, and you'll be applying these principles almost immediately in the labs when you get going. Give everything an ID, link things together, use the standard methods, support multiple representations, and remain stateless. Stateless being an inherent property of the web. For IDs, we incorporate our IDs into our URLs and other resources. We're already generating unique IDs in the work we've done to date, so taking that extra step isn't going to be a big deal. But those IDs become quite prominent in the way we formulate the APIs themselves. We'll see that shortly. Link things together. If we're passing data around or via an API, we're passing links as often as we are passing core information. This is a piece of XML to represent an order, and the order's product and customer ref are other URLs that can be accessed using HTTP should those details be required. And note also that all those URLs contain IDs. 3, use standard methods. We've reviewed those very quickly there in the earlier talk. Get, put, post, delete. Get retrieves something. In an API context, we're getting some information. Post adds or commits or uploads or creates something, which it creates a resource. Delete is if we intend to remove a resource, and put, update. These methods are already supported. They're part of the protocol. They're understood by all the layers between our client and whatever server we're targeting, particularly any caching layers. So we know they're reliable, and we know they work. Allow for multiple representations. We toured some of the representations there earlier, XML, YAML, and so on. 2 of the more common standards in APIs would be JSON and XML. particularly now JSON, largely because many of the clients are often JavaScript, so there's a very low overhead of using JSON. Also, programmers like it. It's easy on the programmer eye as such. Communicate statelessly. This is the way that web works anyway. For retrieving something, for retrieving a customer order like we just looked at a few seconds ago, we're going to get back the order details like we discussed. If I want to now retrieve some more information about the customer, then I'm just doing another request. In the interval, I don't really care what happened to the server. The server could have shut down, updated, restarted, and so on. Doesn't matter. Every request is independent and has enough information in the request parameters for it to be interpreted by the server itself. So those are the principles, and again, they're not principles that are particularly profound or sophisticated. In fact, they are the way HTTP works anyway, and they will enable us to develop APIs that work seamlessly across the existing web infrastructure, not requiring additional layers. So what does all that mean for the little app we're building? Well, let's look at that now in a little bit more detail. We already have a Java app we've built. We actually called one of our classes API, so we seem to have an API in there that we want to expose or make available. The API we've evolved is currently made available to CLI, which has delivered a command line interface to our little app, so that you can run it and on the console type these commands and they have some effect, create users, we can log in, add activities, locations, etc. It's a self-contained app though that only has a single interface. That single interface is the command line interface running on a console. We would like to make the API part of that application available over HTTP, such that we could access the service from another client, and ultimately we could deploy our pacemaker service into the cloud somewhere. How do we do that? Well, we'll take this approach here. Building an API requires a range of intelligence in our app that understands HTTP and that understands the REST conventions. In general, we would be looking towards a web framework for this. You may have heard of Spring or Spring Boot or Play. These are well-known and respected Java frameworks. EJB, maybe you've heard of. There's a newer breed, though, of lighter weight frameworks, and we're going to pick one of these. Spark is one of them, and Javelin here is another one. So I'm just out. Probably not production ready yet, but it's designed as a way of building APIs rather than building full web apps. And that's all we want really for the moment. We're not looking, and we won't be looking for full web functionality in your assignment or in any of the material we cover. We just want an API, just to make our app interesting and to allow us to explore some of the principles and also features of the language we've been learning to date. Note also that this one supports Kotlin, which is nice. And we will delve into some of the ways in which it supports Kotlin in a later lab. Not today, though. Here's the application you assembled from last week. Pacemaker skeleton on the left. It's got the API. It's got some models. And you'll see in there, we've got some new classes, REST main and Pacemaker REST service. That's what we're going to be evolving this week. We'll explore that in these slides here. For Javelin itself, well, the beauty of Maven is that if we want, we just bring in new entries in our dependencies in the XML POM file. That's really elegant. I just stick them in here and they will be downloaded and linked into my application automatically. Take a few minutes or so to locate and download them, but I don't have to go fetching them myself from any particular resource. They'll come from Maven Central Hub. Once we incorporate these components then into our app, you will see the Maven dependencies view inside our project expand dramatically. We're including Javelin and 2 other components, but they in turn have further downstream components, which are all required as part of our now new application. Javelin, as you can see, is just one part of this spectrum here, sitting in here. But there's a whole other range of existing open source libraries for building web apps, particularly all of the infrastructure to support HTTP, all of the infrastructure to support JSON, and also you'll see we even have a full-on Kotlin suite of tools here as well. We won't be digging into those just yet. So when we make these changes to our POM file, we're getting web server, full protocol support, full Java JSON translation. First thing you're going to do is we're going to bring in a new main. So we're going to keep the existing main for the moment, and we'll bring in a new main, and this new main will create a Java object called Javelin. And when we call start on that object, we will have created a web server sitting on port 7000, which will sit there until we terminate the app. Ultimately, this web server will expose our API. We'll look at that in a moment. When you run the app now, it'll look slightly different in the console. The Javelin banner will come up. It's loading various bits and pieces, and if it goes okay, that is, if we don't have any crash, we will have our web server visible on this address here. That is, it's visible on localhost port 7000. And in fact, you can browse to it immediately and see what happens. Bring up a browser, go to localhost 7000, just type that directly into the address bar. And we immediately get a message that seems like an error message. It's not really. It's just telling us that the particular resource you're looking for is not found. So server is there, I could reach it, but I got a not found message back is what that's telling us. The next step would be to expose some simple API, what we call endpoint. And this means doing a little bit of work inside the new REST main we've just introduced. This launches the server, which is okay, we leave that there. But once we've got the server up and running, we're creating a new object called Pacemaker REST service. And we're calling a method config routes, which is going to prime our web server with specific API endpoints or patterns, as we call them, that it will support. And this is the implementation here. And we're using new Java syntax, lambdas and so on, that Siobhan has been discussing with you. I'm calling a method get on an application object, Javelin. I'm specifying 2 parameters. One is the API path or URL I want to support. And the second parameter is going to be the implementation of that endpoint. And I want a new method called list users to make available my database of users as an API call. Down below on this page, I have the complete implementation. I have the existing API object we've already designed. That's not modified in any way. And then I implement this new handler or action, if we call it that, for the API itself. Now, if it's your first time seeing REST endpoints being implemented, it looks a little bit confusing and challenging. If you've seen this before, then I think you probably know the story, really. But it doesn't actually get much more complicated than this. Every single API call I want to implement is either a get, post, or delete. You can see the use of the word get there. It will have a pattern that represents the API signature / users in this instance. And it'll have an implementation. And the implementation here, you can see, is the first one we're going to do, list users. And we've implemented list users down here. And list users at the moment isn't doing anything. But it should return all of our users in JSON format. That's what we'd like to do. Now we can test this out immediately. And you'll notice how we're testing it. We're just putting in /users into the address bar. And this time we're not getting an error, you'll notice. We're just getting nothing. We haven't implemented anything yet. So we're not getting any error. We're getting a 200 in fact, which means okay. Which means yeah, everything's fine. Nothing failed, at least at this point. Okay, building on that, here is the implementation of list users. It's very simple. The API request delivers what we call a context object. This context object is making available to us the request. That is everything the user requested when they issued the API call. The context object is also making available to us a response or a channel for generating a response back to the browser in this case. So the context object is part of the Javelin infrastructure that you'll be starting to get to grips with. And it has a helpful method called JSON, which if you call it and give it a JavaScript object or set of objects, it will turn those objects into JSON format and send them back. This is quite powerful one line. We'll test that out, and if we had preloaded some users, we'd see the users present on our screen here. That is, we'd see them in their original format. We're going to be using RESTlet client, as I mentioned, instead. This is just printing the return values in a little bit more elegant manner, as I'm showing you here. So we can see exactly in formatted mode what the data looks like in JSON format. These are our endpoints that we want to implement. That is, I'd like to implement get, post on users, on activities, and I'd like to specify IDs within those activities. These are the key patterns we're trying to support in our application. So what will they do? Well, we've just done one. Get users should read all users. That is, give me the JSON of all users in the service. If I issue a post onto the same URL, I've indicated a desire to create a user. If I issue a get and I specify an ID, then my intention is to get just one user, not all users. And then if I want to get an ID, a specific activity, I'm using this endpoint. If I want to create an activity, then I'm doing this. These are typical what we call endpoints in REST terminology. A user's endpoint and then maybe an activities endpoint in this instance. With different verbs having different meanings on the same endpoint in some contexts. So here is how the implementation will start to look. This is the endpoints for implementations in my REST main. You can see, I think, a general idea here. We're using get or post on the app object. We're specifying the pattern. If the pattern contains an ID, notice that the ID is preceded with a colon. And in our style, at least, the implementations of all these APIs is just a single call to our service object. And we let the service object figure out what's to be done. So for instance, if we imagine or try to guess what's going on here, I want to create a new activity object. I want that activity object to be for the user whose ID is specified. So once I create activity, presumably I'm able to retrieve the actual ID, the actual activity object, and then I'm going to be updating my model with that activity object as appropriate. Here is how I would go about implementing the create a new user endpoint. Again, at the very top, that's the general endpoint I'm trying to implement. Here is the REST main pattern or a method I include, which will make the API available. And here is the implementation. And you can see something new here then. First thing I'm doing is I'm retrieving a user object from the context. That user object will have been in JSON. Then I'm using my create user API call. I already have that implemented. I don't need to do that. That's going to work fine. That gives me back a new object, which I am going to be just passing right back to the context, which will ultimately go back to the browser or whatever client requested this object. Here's how it might look in the tools you're going to look at. Here is the URL of the API we want to access. Note that it's a post request we're issuing. And a post request in this context requires that we specify a JSON object, which is a new user details. If I go and press send, then it will generate this response for me. And you will see we're getting back the same user, but the ID is now populated. And I might be making use of that subsequently. Let's take another look at that again for a moment. It's creating the user, and we're going to be returning the new user object back to the client. That is, we're converting the incoming JSON object to Java. We're creating an object using our pacemaker, and we're converting that object back to JavaScript so that the client can decide what to do with it. Here's another example. This one is create an activity. A little bit more work to do here. Create an activity, we've got to figure out, well, what user is going to own that activity. So I've got to look for that user. Once I've found that user, then I've got to go off and create the activity, get the activity back, and so on and so forth. So here is how we're doing it. We retrieve the ID from the URL this time. That is the ID of the user. We look up the user in our pacemaker service. The user is not null. We recover the activity from the payload. We then create the activity and return it. Here's an important point. If the user did not exist, if the ID was incorrect, we're returning a different code. We're returning a 404. If you've been using the internet at all, you might notice or remember that number, the not found number from HTTP, which is often visible on broken links. We regard a request for a resource that doesn't exist, in this case creating a resource for a user that doesn't exist, as a 404 error. And we expect that to be communicated back to whoever called it. We expect that client to understand what 404 means, which in HTTP terms means not found. So that's the type of code you'll be starting to evolve in the lab both this week and next week. And that's a little bit impenetrable when you look at it initially, but the pattern is almost always the same, really. Inside in REST main, as we're calling it, we write a method to associate either get, post, or delete with a pattern, and we will have the appropriate call triggered when that pattern occurs on our incoming channel. And our implementation of the method to realize this feature usually takes on this pattern here. That is, we are receiving the context object, which describes all aspects of the request and provides us a channel for the response. And then finally, we retrieve IDs from the URL. We maybe use those IDs to look up aspects in our service, particularly the user in this instance we're trying to identify. And then we may be retrieving additional information from the request. Particularly, we're retrieving the body. Finally then, once we've got the information we need, an activity in this case, and the ID of a user, we already have a method for implementing the creation of the resource. It's in our Pacemaker API. Success means we give back to the client a new activity object. Failure means we tell them, well, I couldn't find that user. So if that's the case, I'm going to give you a 404. Okay, that's quite a lot of material there now. I see some people asking some questions and helping each other out. That's great. It's the start really of your journey into building an API, perhaps for some of you. Maybe some of you have seen this elsewhere in the past. It's quite an interesting field, and its tools we have are quite sharp and concise. So when you get into the lab, you will have a web server up and running well, very quickly, in fact. Step 2, you'll have integrated the libraries just by incorporating these extra components. Step 3, you'll be running the Javelin server, and you'll be exploring, as I've guided you here, the basics of getting that API visible and available. In step 4, you'll be making available the users. Initially, there'll be no users available. In step 5, you will see that you can implement a simple mechanism for retrieving these users here. Step 6 takes you into exploring a little bit the RESTlet extension I mentioned, so you can probe the APIs in a bit more user-friendly manner. And in step 7, giving you a range of other endpoints to implement and then explore those. Exercises are, see if you can have a go at 1 or 2 other endpoints based on the examples that I will have given you. And I'll give you the solutions to these endpoints next week in next week's lab, so you can have a crack at them and see how far you get. That's it for today. I'm going to hang around a little bit on the chat there in case people have any more questions. The lab moves you on now, as I said, taking the skeleton and making it available as an API. Next week's lab will go a bit further in that we will be taking the command line interface and hooking it up to your API, so your client and server are decoupled. So we're starting to move towards building a service with multiple clients, perhaps. And the week after, we start to build some tests for that. maybe get the API deployed to a cloud service. And in our final lab, we'll take a bite off a little bit of what we implemented and see if we could make it simpler using Kotlin. But Kotlin, very much an optional part of your assignment, so I wouldn't go jumping into Kotlin just yet, unless you have a lot of experience in Java already. Okay, that's it for today. An hour and a half, that's about right, I think, for these sessions. I'll put the recordings up as soon as I can. Siobhan will be with you next week to look at some more principles, give you some more guidance on using REST in our skeleton project. And she also is going to revisit some more testing strategies, which hopefully you're getting a little bit addicted to now at this point. I'll see you the week after or the one after that. We're not quite sure yet. Thanks for your attention, and I'll chat to you now if you like for a little while, and then I'll be in touch in the labs tomorrow, obviously. Okay, take it easy, and talk to you next time. Enjoy Thanksgiving, our US friends. Hope you have a great day. Bye.